Now, one of the things that this is also another thing that can trip up people when they're first doing electronics is how do you measure voltage and how do you measure current? Now, this is a circuit. This is just resistors that are in series, and then these three are in parallel. So then if we want to measure the voltage, we would use, in this case, a multimeter. Now the question is, what voltage do we want to measure? The voltage is always in reference to a point. So you don't have a voltage at this point, or you don't have voltage at this point. You have voltage at this point in reference to something. And that something's usually ground. So here I'm gonna decide my ground is actually the ground of the power supply. So I'm gonna connect it to over here. And I'm gonna try to use this. So now if we measure the voltage at this point in reference to ground, or 0 volts, I think I have it set to 5 volts. Now, wait, adjust that so it's more like 5 volts. That's close enough. Now this is a 1K resistor, a 1K resistor, a 1K resistor, and 3 1K resistors in parallel, which I think that should be 333 ohms, if I do my math in my head right. But basically we should have equal, well, not an equal voltage drop here, but so let's just measure the voltage at this point. So here we have 3.56 volts. Here we have, let's just call that 2 volts. And here we have basically half a volt. So now it's all in reference to this ground point. Now if I want to measure, let's say I want to measure the voltage across this one resistor. I want to see how much voltage drops across that resistor. This tells me the voltage drop across the entire thing. So I want to use my reference. I want to move that over to here. Now I can measure this. So now the voltage across that resistor is 1.5 volts. Now let's say I want to do something fun. Let's just say I'm going to use this as my reference, that same point, but I want to measure the voltage at this point. This is, again, it's in reference. So the potential at this point is higher than the voltage at the potential at this point. So I should get a negative voltage. So here I get negative 3 volts. Now you might think of negative volts as like it's a different kind of voltage. It's like a different flavor of ice cream. But the voltage is always measured in reference to a point. So here we have a higher potential. It's almost like if you have a ball falling downstairs. You know, if you measure the potential of the height that it will fall, it's always in reference to something. So like if you measure the height of the stairs, that's your reference, and the ball is going to fall in reference to this point, it's going to fall a negative distance. But if you measure it, if your reference is the ground and the ball continues to fall, it's falling less and less of a height. So it's less potential, if that made any sense. So if we want to, knock something off there. Now, so voltage is always either across something or in reference to something. But we want to measure current. I forgot to mention, also setting up the voltmeter. I know I'm measuring DC voltage, so I've got it set up to measure voltage DC, which is I've got these like nice solid line, and I'm also have my, let's unplug this so you can see a little bit better. So this is the common point. This is always the reference of the multimeter, and it's always good to match up colors. Otherwise, you'll mess yourself up, and you'll get negative voltage when you think you shouldn't. And whenever I'm measuring voltage, I want to be on this side, so like I had before. But now we want to measure current. So if you don't know what current it is, you want to use either one of these two. Now, if you don't know the level of the current, you always want to use the higher. So this is basically a short. So this is, it has very little, it has next to 0 resistance. So if I'm hooking up something and the fuse is rated for 400 milliamps, and I hook up a current that runs through it that's more than 400 milliamps, it's going to blow the fuse. These fuses actually cost a good amount of money. So you always, if you don't know what the current is that's going through it, you always want to plug it into here. But we know this is all pretty low current, so we're just going to plug it into the 400 milliamps. Now the meter tells me something's wrong. It's beeping at me because I'm still measuring voltage. Now I want to turn this all the way back over to not microamps. Well, yeah, let's actually measure microamps. So microamps or milliamps. Let's actually start in milliamps. So now the beeping goes away. So that's the instrument telling you, hey, you've actually got it hooked up correctly. Now, whereas we measure voltage across a component, current, we want to actually introduce the multimeter into the circuit. So this needs to become basically like think of it as a piece of wire, since there's very little resistance. We actually want to open up the circuit, and we do that by removing a resistor. And since I know that this has the higher potential, I'm going to put this on that. And then here I'm going to connect that. And since it's already on, I don't have a switch. We're actually measuring 1.5 milliamps. Now, obviously that's in series, so I'll remove it, I'll reconnect it. So if I want to measure current at another point, let's say, for example, this parallel network. So what I'm going to do, I'm going to disconnect it there. So the higher potential is here. And then I'll reintroduce it to the same node. Now, I wasn't paying attention. I actually hooked it up backwards. That was all intentional, of course. So now I'm actually measuring a negative current. So all that tells you is that you've got your leads backwards. So the value is still accurate. You just ignore the minus sign. And that's how you measure current and voltage using a multimeter.